Welcome everybody, it's Ramchandra here from Civil Maths Concepts, and today I will be dealing with Integral Calculus lecture number 2, in which I will be dealing with graphs and series and plots, which are very important for understanding the basics of calculus, and advanced graphs are dealt here with, and a question is being shown here: x square into 3 to the power of absolute x cube minus absolute x minus 3. The plot is to be drawn by us, and the concepts are made clear in this particular video, so that any type of graph you can create, and I have given an introduction about the series also. This particular lecture will be not only useful for GATE, it will be useful for IIT JEE advanced students also, IIT JEE main, and also UPSC examination students. And best of luck to everybody. We'll go into the lecture channel. Civil Maths Concepts. In the first class of integral calculus, we have seen the importance of the functions and the plotting of the functions. From there, we have calculated the improper integral values. It's Ramchandra here from Civil Maths Concepts. Today, I will be elaborating the importance of the functions and the importance of the plotting of the functions and graphing of the functions. With that, how we can arrive at integrals and how important it will be for the GATE examination, IIT JEE advanced examination, UPSC examination, and other competitive examinations like Maths Olympiad. Now, let me start with, today is the second class, that is integral calculus, lecture number 2. In the last class, we have discussed about integral x by ln x dx, definite integral with different amounts of intervals. Now we have, in that class we had spoken about exponential integral also, and what is the value of that exponential integral for different values of x. From that we had drawn the graph also. Now, let us take a simple function. Let us take a simple function for our further understanding. X ln x. Integral of x ln x from 0 to 1. What will be its value? In the same similar fashion, we'll put the value of x as 0. Otherwise, we can put the value as x as minus 1. Minus 0.5, 0, plus 0.5, and plus 1. What we have to do is to worry about 0 to 1. Even though we plan to go for minus 1 to plus 1, our more interest will be from 0 to 1. Let us calculate ln x. For 0, what is the ln x value? Minus infinity. For 0.5, what is the ln x value? Minus 0.693. We know about it. We have done it in the last class. For x is equal to 1, ln x is equal to 0. Now, what is x into ln x? This we can write it as 0. It will be 0.5 into 0.693. Please do calculation. Minus 0.3465 and it is 0. Then from 0 to 1, how the graph looks like? The graph looks like this. 0. .5 and 1.0. This looks like this. This value will be minus 0.3465. Usually, what will be the portion? This portion. When you consider a rectangle of the shape side 1 and another is 0.3465, the total area of the rectangle will be 1 into minus 0.3465. What will be its approximate value? If it is curved like this, like a parabola, what will be its value? Its value will be approximately 3/4 of the rectangle into 3 by 4, that green shaded area. Then what will be its value? 1 into 0.3465 into 3 divided by 4. That is approximately 0.26. What is the value of integral 0 to 1 x ln x? Its value is minus 0.26. This is one of the GATE examination questions and value is given as minus 1 by 4. This is the correct answer. Because we have done numerically the problem, we solved it numerically in just 2 steps. In few seconds we got the answer. But if you go traditionally by finding the exact this integral x ln x, then it will take few minutes. Please save your time in the examination. For saving the time, graphical calculations will definitely give you an advantage over traditional calculations. Please. And another question let us take. Why I am harping on these questions? The reason being, you please try to appreciate the importance of the method which I have been teaching you the calculus from the first class itself. Just find out the value of log 1 plus x divided by 1 plus x square dx. It's a very lengthy problem. It takes time. When you go traditionally, then let's go with geometrical values. What will be the geometrical value? Please make a table. X is equal to 0, then 0.5, then 1.0. You can even have more number of intervals also. In the given 0, 1 interval, you can have 0, 0.2, 0.4, 0.6, 0.8 and 1 also. Only for simplicity I have taken this. Then what is the value of 1 plus x? This is 1, this is 1.5, this is 2. Then what is the value of log 1 plus x? Wherever I call log, it is natural logarithm to the base e. This is equal to 0. This is equal to 0.405. I have already told you, remember the values of log, ln x values. Otherwise, you have been given the scientific calculator. In the examination, forget, you can solve from there also. But if you remember, it will be faster. 0.405, then log 2 is plus 0.693. Just remember, even in the previous class, I told you 0.5 is minus 0.693, whereas ln 2 is plus 0.693. Next, what is the value of 1 plus x square? 1 plus x square is, for x is equal to 0, it will be 1. For x is equal to 0.5, it will be 1.25. For x is equal to 1, it will be 2. Now, find out this is the function. Log 1 plus x by 1 plus x square. That is the function x. Then what will be the value of function x? Log 1 plus x, that is 0. 0 divided by 1 is 0. When x is equal to 0. Then when x is equal to 0.5, log 1 plus x is 0.405. 1 plus x square is 1.25. 0.405 divided by 1.25, it gives 0.324. You please cross check from your calculators. Then log 1 plus x or from your regular arithmetics. Log 1 plus x is 0.693 plus divided by 1 plus x square is 2. Then what will be its value? 0.3465. Now I have got the function values. Then let me draw 0 to 1. At 0, at 0.5 and at 1. I want 0 to 1. At 0, function x is 0 and at 0.5 it is 0.324 and at 1, 0.3465. Now, you draw, find out the area of this green shaded portion. What will be area of this green shaded portion? From your regular trigonometry and your geometry, your elementary school mathematics. This portion is like a triangle. It's not a triangle, it's a curve, because it's not straight lines, it's curve. Let me draw like this. This curve, whereas in the first problem the curve is very sharp. It's very close to, zero values are very close to this y-axis, whereas here they are away. So that this value, let me take it as 2/3. And this is a rectangle. And this portion, another 2/3. If it is like this, please look at it. This can be approximated to 3/4. Something is like this. This portion we can approximate to 2/3. Like this is 2/3, whereas this will be 3/4. This is almost occupying the 3/4 portion. This is occupying the 2/3 portion. Now just see what it happens. 2/3 into 0.324 into 0.5 plus 0.324 into 0.5 plus 0.3465 minus 0.324 into 2/3 into 0.5. This is approximately equal to 0.27. The approximate value of this is 0.27. The correct value, when you do this whole problem traditionally, you will get the same value, almost approximate value. That means what I am conveying here. Here what I am conveying is that whenever you feel that you are unable to do the mathematics portion of a particular definite integral given in the examination, go for the geometrical interpretation, get the approximate values, or whatever, if you can get the exact values, approximate to some 3 decimal, 2 decimals, taking more partitions in the given interval, and you check your alternative to which that answer will be applicable and put it that as answer. That means, in case if you are unable to solve any problem in a traditional manner, then you can do it in the geometrical manner. It's called as a numerical method. In numerical method, you solve the problem, get the answer, compare it with the given answers. If it is 0, infinity, like that, you can definitely eliminate the answers. Some answers are negative, positive. Here you just see, first question, the answer is -1/4, which is -0.25. Whether our geometrical answer is coming as -0.26. Other alternatives are given as 1, -1, and infinity. That means other alternatives are nowhere near the real alternative. You can choose very safely and you can get the marks. Even though if you are unable to do the traditional integration, this is one method. Even after doing the traditional integration, if you have any doubt, spend a few seconds finding the geometrical answer also and compare both of them and see that your answer is accurate. Accuracy of the answer is more important than spending a minute more on the question. Now, when the importance of the geometrical solutions had been understood, now I will give you another simple problem. Geometrically, you try to do it, a simple problem. I will give two problems. One is integral 0 to 1. Do it geometrically. Is equal to how much? First problem. Second problem, you take it as 0 to 1 x ln x whole cube dx. These two problems you solve geometrically and try to go for traditional method also, and you just see whichever that suits better for you. You please follow that method and get the answers and score better in the GATE examination. Next, okay, we have developed a system where geometrical meanings are given, some amount of introduction by me, and their importance was told. Now, I have used a word numerical methods. The traditional procedures will call for accurate values, whereas numerical methods, where integrals are not being solved with the traditional methods, or if they go for lengthy solutions, where time is a constraint, or the coding in the computer is a constraint, in that conditions, we have numerical methods to solve many difficult, unsolvable integrals by traditional methods. The two famous methods are there. One is trapezoidal rule, another is Simpson's one third rule. Now I will explain these two. Trapezoidal rule means the formula is straightforward. It is h by 2 into one interval is given. That interval is divided into different portions, different parts. Like 0 to 1 is given, and we have taken the parts as 0.3. In that case, 0 to 1, 0.2, let us say. In that case, 0. 0 to 1 with 0.2 partition, we will get 0, 0.2, 0.4, 0.6, 0.8 and 1.0. How many are here? 1, 2, 3, 4, 5, 6. 6 points are there. For some function, 6 points are there. Trapezoidal rule says h by 2, whatever this partition value, this is h. What is that partition? Is 0.20. h by 2 into first plus last. First plus last first value plus last value plus 2 into remaining values. The remaining values of y of function x. The interval is 0 to 1, that is x. X is divided into different parts, that is into 6 parts. And first element plus last element plus 2 into remaining elements. Function x values. Function x values. These are all x values. There is one function x we call. Function x may have some value as x1, x2, x3, x4, x5, x6. Function x, first is x1 for x is equal to 0 and last is x6 for x is equal to 1 and second is x2 for 0.2, 0.4, 0.6, 0.8 and 1. Now, trapezoidal rule says h by 2 into first value of the function x plus last value of the function x plus 2 into remaining values of function x. This is the value of the integral in the given interval. What Simpson's rule says? Simpson's 1/3 rule. Simpson's 2 rules are there. I am talking about 1/3 rule. h by 3 into first plus last. First plus last is same in both the cases, plus 4 into even plus 2 into odd values of function x. What is the even function x? It is x2 here, x4 here and xx is the last one. We should not take it. First and last plus 4 into even, there are 2 evens and 2 into odd, that is x3 and x5. x1 and x6 already taken care of in the first plus last. This is Simpson's 1/3 rule. While doing the problem, we will understand better. Then Simpson's 3/8 rule. What is that? Instead of h by 3, it will be 3h by 8. First plus last will be same. Here instead of 4 into even, it will be 3 into even. Plus instead of 2 into odd, it will be same 2 into odd of function x values. Now, you might have understood. Even with these rules, by numerical methods, we can find out the approximate value of the definite integral. Improper integrals, definite integrals of difficult problems, lengthy problems, all these can be easily solved by these 3 methods. Out of my experience, I can say the second method, Simpson's 1/3 rule, gives a better approximation when compared with the other rules. Now let us solve one problem. There is a problem given in GATE. I am taking the GATE questions because they are in the public domain and they are available for everybody to solve. Now let us solve one. Interval is 4 to 5.2 ln x dx. We will apply Simpson's 1/3 rule. And also trapezoidal rule, and find the difference. This big is not the GATE problem. I have taken only the value portion of it, not everything. Simpson's 1/3 rule, trapezoidal rule, and finding the difference, that I made it little bit complicated. So that if you solve the complicated problems together, then you can easily understand the procedure, and whatever tough problem that comes in the GATE examination, you will be able to solve it very easily. Now, interval is, let us take the partition as each partition of length 0.30. Now, interval is 5.2 minus 4, that is equal to 1.2, and partition is 0.30. Then it starts like this: 4, 4.30, 4.60, 4.90, and 5.20. How many points are there? 1, 2, 3, 4, 5. This is x. Then what is the function x? Function x is equal to ln x. And what is the ln for? 1.386. What is the ln 4.30? 1.458. What is the ln 4.60? 1.526. What is the value of ln 4.9? 1.589. What is the value of ln 5.2? 1.649. Now we have got the function values for different x values. This is x1, this is x2, this is x3, this is x4, this is x5. Function value. This is what we have defined. Function x, I told x1, x2, x. Or you call it by any name, no problem. Now what is Simpson's rule says? What is Simpson's value? 1/3 into h. What is h? 0.3. First plus last, what is first? x1 is 1.386 plus last is 1.649 plus 4 into even. What is even? x2 is even 1.458 plus x4 is even 1.589 plus 2 into odd. Odd is only one odd is there. 2 into 1.526. Because last and x5 is already, x5 and x1 are already taken as first and last. Now, when you do it, as per Simpson's 1/3 rule, the value of integral is equal to 0.3/3 into 18.275, that is equal to 1.83. This is the answer. As per Simpson's rule, that is the answer. Now, as per trapezoidal rule, what trapezoidal says? What is trapezoidal rule? Please remember, h by 2, first plus last, plus 2 into remaining. H is 0.3. 0.3 divided by 2. First is 1.386. Last is 1.649 plus 2 into remaining. 1.42 into 1.458 plus 1.526 plus 1.589. Do it. Let me do it. 1.386 plus 1.649 plus 2 into 1.458 plus 1.526 plus 1.589. This is 12.181 into 0.3 divided by 2. 1.82715. 3 digits, let us say. This will be 1. If you make it 3 digits, 4 digits, 1.82, sorry, 1.8275. It is 1.82715. 1.8275. It is. Therefore, what is the difference? 1.8275 minus 1.82715. That is 0.00035. This is the difference. And what is the percentage of difference? Percentage of difference is equal to 0.0035 divided by Simpson's value, 1.8275 into 100. .02%. That means almost the Simpson's 1/3 and trapezoidal values are matching. But however, Simpson's 1/3, it's better to use Simpson's 1/3 in the examination. That's my advice only. Nothing concrete. You can use any method. That's up to you, which you feel easy. Now, Simpson's 3/8 rule also you can use. Now, as a homework, use Simpson's 3/8 rule. This is all about integrals, definite integrals, finding the values. But however, all this requires a little bit of more depth in understanding the integral calculus and calculus for that matter. It's not that one integral is given to find out the value. There may be questions like this, but that is not the end of integral calculus. Integral calculus is something different. It requires differential calculus also, understanding of the functions, understanding of the behavior of the functions and series, and understanding of the differential calculus. From integrals, now we will move to functions. From functions we will move to series. From series we will go to differential calculus. From there we will go to differential equations. Very, very important topic. There are 4 steps to reach differential equations. Now, let us go to functions. Very important. Please pay attention. Functions and graphs. Everything is made. The pattern of teaching is made by me. Nothing is as per book. In the book, you may be seeing functions first, sets of functions, and then your differential calculus and integral calculus and differential equations. I am going in a totally different way, entirely different from the class books. Because here, in a systematic way, the subject is to be understood. Subject, I feel, the subject will be understood in a better manner in this way. The way I feel it is so, and people when they are it is up to their comfort of understanding, they can go back to the other system also. But everything will be covered here. Everything will be covered here. Now, let us go to a simple function. Function x is equal to x. What it means? What is this? Function x is equal to x. Let us draw it. It is xy axis. Function x is taken on y axis. Function x is taken on x axis. Now, you tell me, how do you draw function x is equal to x? If x is equal to 1, function x value is 1. If x is equal to 2, function x value is 2. If x is equal to 3, function x value is 3. Please pay attention. If x is equal to minus 1, function x value is minus 1. If x is equal to minus 2, it may look very simple. Please try to understand the concept. Function x is minus 2. If x is equal to minus 3, function x is equal to minus 3. Now let us draw. If you see, you connect all these points. It's a straight line having some slope. If function x is equal to y, then it will be y is equal to x. With a slope 1. It's a straight line. In y is equal to mx plus c, intercept c is equal to 0 and m is equal to 1. That is what is function x is equal to x. Now, let us go for function x is equal to absolute value of x. When we say absolute value of x, that means function x is always positive. Whether x is negative or positive, function x is always positive. Function x is always positive. Function x is always positive means it is always above x-axis. It is symmetrical to y-axis. What is the absolute value of x? Is equal to, if x is plus also, the value is plus. If x is equal to minus also, the value is plus. Always positive x. Now, let us draw this. These things may look simple, but try to understand the concept so that in the examination, very simple functions only are given. In 2024 also they are given. In 2023 also they are given. And you can answer the graphs of the functions in seconds when you understand these. When x is equal to 1 plus 1, function x is equal to plus 1. Because absolute value of plus 1 is, when x is equal to 2, it is plus 2. When x is equal to minus 1, then also function x is plus 1 only, because it is absolute value. When x is equal to minus 2 also, this is plus 2 only. Now, let us combine these, and the graph looks like this. Simply, the absolute value is taken, function x is equal to absolute x value, then the graph is like this. Graph is like this. This is x, this is function x. Now, let me go for some little bit, we'll make it complicated. Now, let's go for something else like this. Function x is equal to x square. What happens? The graph will be, whatever the value of x, whether it is positive or negative, the value of y, that is function x, will always be positive because it is x square. That means it will be parabola like this. Sorry, the parabola will be like this, touching the origin. Now, function x is equal to x cube. What will be the graph? This is x, this is y. When x is equal to positive, function x is positive. When x is negative, function x is negative. For function x is equal to x cube, for negative values of x, function x will be negative. For positive values of x, function x will be positive. The graph will look like this. Then let us take another function. These functions may look simple, but it is required to understand them, each one of them. Function x is equal to absolute value of x cube. In this case, for whatever the value of x, whether negative or positive, function x is always positive. This will be like this. These are all continuous functions. At present, we are not dealing with the discrete functions and discontinuous functions or step functions. We will be slowly moving towards them. Then, let us take another function. Take a function. Function x is equal to 2 to the power of x or some scalar value a to the power of x. A is any scalar. 2 to the power of x, for example, or we can even say 3 to the power of x. Let us take 3 to the power of x. What happens? Let us see. For the value of x is equal to 0, the value of function x is equal to 1. For the value of x is equal to minus infinity, the value of function x is equal to 3 to the power of minus infinity, that is equal to 0. And for the value of x is equal to infinity, 3 to the power of x is infinity. Then the graph looks like this. This is x, this is function x. For negative values of x, as the negative value increases, the value of function x decreases. That means function x will be decreasing like this. This is the 3 to the power of x function. Now let us take another function. Function x is equal to 3 to the power of absolute value of x. Here, whether x is negative or positive, three to the power of absolute value is always positive only. Absolute value of x is always positive. Now in this case, how it will be? Think over. It will not reduce for the negative values of x, whether it is negative value or a positive value, after a certain minima. Where x is equal to 0, it will be touching 1, the y-axis, function x-axis, and the value on either side of the function x-axis will be moving upwards only, increasing only. The answer is like this. These functions, this type of functions are given in the GATE exam. Please try to understand them. This is value 1. This is 0. This is the function x, 3 to the power of absolute x. And then function x is equal to 3 to the power of minus x. How it looks? This will be For the positive values of x, it will be going towards 0, because minus infinity, x becomes positive plus infinity, then it will be 3 to the power of minus infinity, it will be 0. For negative values of x, it will be increasing. It will be the reverse of function x 3 to the power of x. It will be like this. At 0, x is equal to 0, the value will be 1. This is 1 when x is equal to 0. Now, let us do some more. Let us say, what will be the function of x and x graph if something absolute value of 3 minus x? Let us say 3 minus x. What it looks like? We have seen absolute value of x. Something scalar minus x, absolute value we have not seen. Let us see. For values x is equal to 3, function x is equal to 0. If x is equal to less than 3, then function x will be always positive, whatever be the value of the x. For example, x is equal to 3. What is the value of function x? That will be 0. X is equal to minus 3. What will be the value of y? Function x is equal to, it is minus 3. It is 0. X is equal to 0 means it is plus 3. X is equal to 0 plus 3. X is equal to plus 3. Then function x is equal to 0. Let us draw like this. X is equal to minus 3, 0, plus 3. What will be absolute value of 3 minus x? That is equal to 3 minus x will be 3 minus 3. That is minus 6. Plus 3 minus 3. That is 6 plus 6. When x is equal to 0, it is absolute 3 is equal to 3. When x is equal to absolute plus 3, then it will be 3 minus 3 is equal to 0. You understood? Minus 3, it will be plus 6. And 0, it will be 3. And then it is plus 3, it will be. That means the graph will be like this. Now, function x is equal to 3 minus absolute x and absolute. Absolute value of absolute x. 3 minus absolute value of x, absolute of whole value. Then x is equal to minus 3, x is equal to 0, x is equal to plus 3. Then what will be function x? When it is minus 3, x absolute value of minus 3 is plus 3, 3 minus 3 is 0. When x is equal to 0, then absolute value of 3 is 3. When x is equal to plus 3, what happens? 3 minus plus 3 absolute is plus 3, 3 minus 3 is equal to 0. How to draw it? This will be, this is x, this is y, this is minus x, this is minus y. X is equal to minus 3. Y is equal to 0. That means it is on the x line. When x is equal to 0, y is equal to plus 3. When x is equal to plus 3, y is equal to 0. That means it is like this. Try to follow. This is very, very tricky question. Next comes function x is equal to then it will be like this. then it will be like this. Function x is equal to 2 minus absolute x. When x is equal to 2, 3 minus absolute x. X is equal to minus 3, x is equal to 0, x is equal to plus 3. We are only doing it for 3 points. When x is equal to minus 3, 3 minus of absolute is plus 3, same 3, 3 minus 3 is equal to 0. When x is equal to 0, that will be 3 minus 0 will be 3. When x is equal to plus 3, three minus 3 is equal to 0. Then when x is equal to plus 6, what happens? It will be minus 3. Function x will be, this is 3 minus 6 is equal to plus 3. Because it is not absolute, whole value is not absolute, function x can take the negative values also. Function x can take negative values also. How the graph will be? This is a typical graph. Please try to understand the difference between previous one and this one. X is equal to minus 3, y is equal to 0, x is equal to 0, y is equal to 3, x is equal to plus 3, y is equal to 0. When x is equal to plus 6, y is equal to minus 3. Just to see, the graph is like this. This is different from the previous one. Previous one has got total absolute, hence the previous one was above the y-axis. Whereas in the second, here, it is not, total absolute is not there, hence it can even go below the x-axis also. Now, let us go for a question. Find the suitable function for the given graph. Here, graph is given. Find the suitable function. Graph is given. Graph is given like this. Let me give the graph like this. This type of question is asked in GATE 2023 in mechanical engineering. Very good question. I have little bit changed it. You just see. The graph is like this. The graph is like this. Now, you just go back to the previous page, just to see which one is similar to this. Function x is equal to total absolute of 3 minus absolute x is the function. This implies answer is function x is equal to absolute value, because whenever the function x value, that is y value, is always above the x-axis, then it's nothing but an absolute value. This is what is the answer. Could you get it in seconds? Yes. This is how we have to solve the problems. And another typical problem, I'll give the graph. You find out the equation and tell me. Graph is I will give 4 graphs. You find the equation. We'll debate in the next class. One graph is like this. This is, let us say, A. Another graph is like this. Whatever I have taught you till now, from there only I am giving. This is B. Another graph is like this. This is C. Another graph is like this. There may be different functions. Find out the typical function or any function which you feel like, which gives the graph like this. Which gives the graphs like this. Please try to find out the graphs, find out the equations for the graphs given, give some work to your mind, think over and find out. And if you want some more graphs, and you can refer to either Thomas calculus or, as I told you, mathematical analysis by Rodin and Tom Apostel. And it's always better if we go with the graphs and understand the graphical meanings and do the mathematics. The general, you can easily find this one. Another question I want to give. Simple one, which everybody knows. A waveform. What is this? Then can you draw e to the power of x? Draw log x. I have already shown you, ln x. Try to draw again. Then from these graphs we can say a particular function is increasing or decreasing, and the behavior of the function. From the behavior of the function we can go for the integral values, and when we find out the tangent to these curves at a particular point, that refers to the differentiation. Now slowly we can move from integrations to differentiation, but however it will be too early. We have to take care of the series, sequences and then differentiation. Now the graphs, whatever I have given you, if you can draw them and understand them without any difficulty and draw the trapezoidal, find out the integral with the help of trapezoidal rule and Simpson's rule, that will also be very helpful to you in the examination. In addition to that, I want to give a little bit of introduction about the series. Integral calculus we will be doing further because there are surface integrals, then double integrals, triple integrals, they all come. It will be too early, it's a single variable integrals we are doing. We are not doing double integrals, triple integrals and surface integrals, line integrals, Stokes theorem. These we will be taking up. I have given only the introduction of the integrals, and I am developing a base for you to understand what is calculus. Then we will delve into the depth of the calculus. Calculus may not be less than 10 classes. It will be more. It's a very big topic. Now, you may be having some knowledge about the complex plane. And in the complex plane, for a unit radius circle, the equation is, if theta is the angle, the equation is e to the power of I theta is equal to cos theta plus I sin theta. Please don't forget this formula. It's very useful in almost all the engineering applications. E to the power of I theta is equal to cos theta plus I sin theta. E to the power of I theta is equal to cos theta plus I sin theta. How it will be useful, I will tell you now. What is the series expansion of e to the power of x? Series expansion of e to the power of x is equal to, for any value of x, 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3 plus x to the power of 4 by factorial 4, and go on. This is a very, very, very important series. Please do remember this. Please remember the previous one also. E to the power of I theta is equal to cos theta plus I sin theta. Now, if I replace x with I theta, what happens in this series? What happens? E to the power of I theta is equal to 1 plus I theta by factorial 1 plus I theta whole square by factorial 2 plus I theta whole cube by factorial 3 plus I theta whole to the power of 4 by factorial 4 plus go on. We know I square is equal to minus 1. I is an imaginary number. Square of I is equal to minus 1. When we apply this in this e to the power of I theta, what happens? E to the power of I theta is equal to 1 plus I theta by factorial 1 plus I square. I square theta square is minus 1 theta square by factorial 2 plus I cube is nothing but I square into I. I square is minus 1. Minus 1 into I into theta cube by factorial 3 plus I square is minus 1. I square into I square is equal to I to the power of 4. That is minus 1 into theta to the power of 4 by factorial 4, and go on. Which implies e to the power of I theta is equal to one plus I theta by factorial 1 minus theta square by factorial 2 minus I theta cube by factorial 3 plus theta to the power of 4 by factorial 4, and go on. Which implies e to the power of I theta is equal to, let us take all I common and real values separately and imaginary values separately. When you separate imaginary and real values, what happens? 1 minus theta square by factorial 2 plus theta to the power of 4 by factorial 4, and go on. This is real number plus imaginary number will be theta by factorial 1 minus theta cube by factorial 3 minus theta to the power of 4 by factorial 5, go on. This is plus. Now, let us compare what is e to the power of I theta. E to the power of I theta is equal to cos theta plus I sin theta from the definitions of complex variables. This is nothing but in the expansion form what it is? 1 minus theta square by factorial 2 plus theta to the power of 4 by factorial 4, and go on, plus I into theta by factorial 1 minus theta cube by factorial 3, and go on, and so on. Then let us compare the real numbers with real numbers, imaginary numbers with imaginary numbers. Ultimately, cos theta is equal to 1 minus theta square by factorial 2 plus theta to the power of 4 by factorial 4, and so on. This is a very, 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 very important derivation in series. And sin theta is equal to theta by factorial 1 minus theta cube by factorial 3, and so on. These two you please remember with the help of the derivation. Why I derived this? Because when we derive, we'll understand. When we do maths, we'll understand the maths. There is nothing called by hearting the formula in mathematics. Now, from the above, for example, hyperbolic function I want, sine hyperbolic theta and cos hyperbolic theta. When I remove the negative signs in the above equations, that will be hyperbolic. Remove the negative, that will be hyperbolic. Then what will be hyperbolic? Cos hyperbolic theta is equal to 1 plus theta square by factorial 2 plus theta to the power of 4 by factorial 4 and so on. What is sine theta? Sine hyperbolic theta? Theta by factorial 1 plus theta cube by factorial 3 plus theta to the power of 5 by factorial 5 and go on, so on. You see how beautifully we are arriving at the series with a simple complex analysis e to the power of I theta with a unit radius circle. E to the power of I theta is equal to cos theta plus I sin theta. Please remember that. Then another important series you may be required to understand is ln x. ln x in polynomial form or series form we can write like this. ln x is equal to x minus 1 minus x minus 1 whole square by 2 plus x minus 1 whole square by 3 minus x minus 1 whole to the power of 4 by 4 and go on, so on. When ln x is there with you, e to the power of x is there with you, sine hyperbolic theta is there with you, cos hyperbolic theta is there with you, cos theta is there, sine theta is there, and then your e to the power of I theta is there, then can we find out log 1 plus x? That is ln 1 plus x and ln 1 minus x. Yes. I'll give it as a homework. Write expansion series for log 1 minus x and log 1 plus x. You please take it as a homework and do it. Next, don't forget the binomial theorem also, ultimately. What binomial theorem says? 1 plus x to the power of n is equal to 1 plus nx plus n into n minus 1 by factorial 2 x square plus n into n minus 1 into n minus 2 by factorial 3 x cube and so on. There are Taylor series, Maclaurin series, there are many series. We will be definitely taking up those series, and those when we take up the complex calculus. That is the calculus of complex numbers. Residual theorem, when we deal with, we will try to understand the complex theory. Now, one more question I want to give you. Find integral 0 to 1 e to the power of x dx by trapezoidal rule with 4 intervals. Four equal intervals. What are the 4 equal intervals? Will be 0, 0.25, 0.5, 0.75 and 1. This is one interval, this is second interval, this is third interval, this is fourth interval. As I told you, trapezoidal rule, you try to find out that value. This is also one of the questions given in the gate. And the graphs which I have asked you, you please try to solve on your own. If you require these graphs, I made on by myself. The questions are given in a twisted manner in the gate papers. You can refer to GATE 2023 and 24 papers of mechanical engineering, and then civil engineering and electrical engineering, so that You can see the graphs, even civil engineering, mechanical engineering, electrical engineering, and even go to electronics and communication engineering also. What are the equations there? Equation was given with the graphs. Either you develop the graphs and go back to questions, or take the questions from the gate papers and develop the graphs and compare my graphs and give the answers. In the next class, we are going to solve these all 4-5 graphs which I have given you. And try to find out this also. Value of another question I want to give. Why I am giving this much number of questions? Because practice makes man perfect. Interval is 0 to 1 by 2 e to the power of minus x square dx by trapezoidal rule. And Simpson's rule. Simpson's 1/3 rule. And find the difference. Yes, take the tough questions. Take h is equal to 1 by 8. Then we'll further move to series in the next class. Odd function, even function, series. Just try one small problem. Try to read Taylor series. What is Taylor series? You try to read. Be prepared for the next class by reading the Taylor series. We'll see what best we can do. In understanding that, the question also you try. Function z is given as cos z plus e to the power of z square. Try to expand this. Expand using Taylor series. The total expansion is not asked in the gate, but they have asked something else from this. They have asked the coefficient of particular z power. But I am asking you to do the general expansion so that you will understand the once you know the general expansion system, then you can answer the question in the gate very easily in seconds. Everything depends. How do you grasp the concepts? It is not what you have to do there. It is how to do it. When you know how to do mathematics with geometrical interpretation, then you will be the master of the mathematics. With this, I want to conclude today's class. If you feel my class is going in right direction, please view in full the first class also. View, review, comment, and if you feel it is going in a right direction and it will be helpful to you, please subscribe to my channel, Civil Mech Maths Concepts. Thanks a lot for listening to me. Best of luck to everybody. Till now in integral calculus, we have done few problems from GATE and also from Civil Services UPSC, solving the improper integrals. And today we have taken up, while solving, what method to be applied. There are 3 methods. One is trapezoidal rule. There are many methods, but 3 famous methods are there. Trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule. All these 3 we have discussed. And for certain integrals, we have numerically found the values and compared with the traditional method values. We found the compliance, and also we found the values from Simpson's 1/3 and also trapezoidal, and we found the difference. The error found to be minimal, but still there is some difference, and this is because the analytical solutions will differ little bit from numerical values. And in this we have discussed the numerical values also. In extensively we have discussed the graphs, and we will further take more and more graphs in the next class. And also we will take up in the next class, our agenda is next class agenda, more graphs plus series introduction. There are many series. We'll talk about the series, then convergence, divergence. It takes a lot of time to understand divergence and convergence. We'll talk about graphs more because these graphs will be useful. Next, we'll try to do something different, like finding the tangent. What's wrong? We'll do graphically. More graphs and series introduction and